Hello, everyone. Well, I'm Erin Massey. This is our final assignment 5, which is a review of an optional paper, or I said a publication review. And the review I chose is proline and hydroxyproline, which is hydroxyproline is a metabolite of proline. Proline and hydroxyproline metabolism, implication for animal and human nutrition. Being a dietitian for people, it's no wonder I chose this topic, right? Because I wanted to see the implications on human nutrition. And it was actually from this class, thank you, Dr. Kim, but I found out that pigs are so closely related to the human digestive system. And this whole time I was thinking it was those monkeys, which aren't domesticated. So I owe that to Dr. Kim and to my classmates for this class figuring that out. I didn't do a full citation here, but you know where to find the paper in the Moodle. And multiple authors on here, including our professor. So, oh, so the first thing we'll talk about is bear with me here. So the background, why is proline significant? Why is this topic significant? Arginine is one of the, obviously one of the major class discussions we have, which is conditionally essential. Arginine, in a nutshell, goes to ornithine, which is not one of the 20 amino acids that we learned. One of the 21, and then that goes to proline. So arginine goes to ornithine, which goes to proline. So essentially, not essentially, arginine, which is a conditionally essential amino acid, has as a product of proline. What is hydroxyproline? In context of this article, it's a metabolite of proline. So also very important. You'll see to contribute to the importance of proline. On a per gram basis, the requirement of proline for whole body protein synthesis, it's the highest among all amino acids. So seems pretty important to me if we have that much of it in our body, right? To continue on the importance of proline, so it's the highest in our body because it's found in collagen. And yet, nutrient requirements of swine and the National Research Council tend to agree that it's not necessary in diets of gestating, neonatal, or growing pigs, nor is there any guidance really provided about needs of protein in the body because they're still considering it non-essential or conditionally essential without burns or injury. So even though we seem to need these massive amounts of this proline in our body, there's still not a requirement amount on it in humans nor pigs. And it's really considered not necessary by the major governing boards. So to continue on the main content of the paper, are they finding, does research suggest otherwise? Does new research suggest that proline could be more essential than maybe suggested? A couple studies here. So the paper also mentions proline found high in pig's milk, specifically milk, right? Because there's a lack of enzymes to break down proline into other products to degrade it. So proline oxidase is actually missing in mammary glands. So that milk is actually going to be very high in proline instead of proline byproducts. Funny enough, milk is low in arginine, which is what there's way more studies looking at arginine and the importance of arginine, but actually milk, which we consider essential to any animal's growth, is low in arginine but high in proline, the amino acid that apparently is not needed, right? So why? So in baby pigs, proline and hydroxyproline makes up 12% of proteins in the body. So it's very important. And proline needs were actually found to increase about 3 times from day 40 to day 114 of life in baby pigs. So they're using quite a lot of proline so that, as we see in many milk studies, at least with humans, milk tends to, to change based on the needs of the baby, of that growing need. Um, and the majority, it seems, proline is one of those needs that is changing to adapt to the needs of the baby. Why again? Like, well, okay, their needs are really high. Well, why can't they make it out of arginine? Baby neonates are unable to properly break down their arginine in the liver like adults do to create an adequate supply of proline to support their really high needs. Furthermore, their intestines are going to break down 40% of the arginine that comes in through the digestional tract. And the byproduct is, of course, even more proline in baby pigs. So not only are they getting it from their milk, but their digestive system, and a arginine spared 40% of the arginine is going to make even more proline. So it seems to be very crucial in that population, young population of pigs. So what else, other than baby pigs and neonates, what other roles does proline have that makes it important? Proline makes something called a polyamine, which is responsible for DNA, RNA, cellular differentiation, cellular migration, and cellular proliferation. So anything that is crucial at the cellular level sounds pretty essential to me. It's pertinent for wound healing in pigs and people, primarily because proline is very, very high in collagen tissues. It makes up about 30% collagen tissues. It's also pertinent for wound healing in that it helps maintain nitrogen balance in those healing cells. We already talked about this, but it has a role in intestinal growth and the general health of neonates who are, again, unable to synthesize adequate amounts of proline in the liver needed for that. But where does it come from? What are some good sources of food as well? So when poly means wound healing, babies have to have it. It's found in meat bone meal, poultry byproduct, and salmon are the highest. And this is going to be 3 to 6 times higher in those products than found in plant proteins. So if you have a need for proline, you'd certainly have to eat, 3 times as much plant protein to maybe meet that need possibly. It's going to start off being digested just like any other amino acid after it goes through the mouth, which breaks down carbs first. Esophagus, it's going to get the stomach. After it goes through the acidity of the stomach, it's going to be broken down in the small intestine by those 5 major enzymes that we discuss. Tryptophan, carboxylpeptidase A and B, not say tryptophan, trypsin, carboxylpeptidase A and B, proelastase, and it'll come to me, and if it doesn't, I have notes. Like, it's late at night, you guys won't watch what happens. Edit. I'm missing one. chymotrypsin. So we have trypsin, chymotrypsin, proelastase, procarboxypeptidase A and B. So after all that, we know we get dipeptides and tripeptides. Specifically, after we get to the dipeptides and the tripeptides in the small intestine, proline is going to be hydrolyzed by a specific enzyme called prolidase. After it's hydrolyzed by prolidase, it can be transported directly to an enterocyte, into the enterocytes, into the cells by a gradient, so passive transport. But only 60% of it is going to be retained in the portal vein circulation, with a vein that can go directly to the heart. Further evidence that was found that supplementation may be warranted and actually has improved impacts, right? It's found to increase the weight of chickens with supplementation to a chemically purified diet. It's found to increase the rate of young pigs with supplementation to a proline-free diet in which proline was then supplemented. Also, it decreased urea output in those pigs, so decreasing waste. It increased the villi size, so the nutrient absorption capacity in the small intestines of young piglets who were eating corn and soybean meal, which was then supplemented with proline. So increasing weight, increasing absorption in general, because your villi really absorbs all of the nutrients that are going through your intestine. Really positive impacts. So my final thoughts on this. The article says multiple times more research is warranted, as always, to look at, is this amino acid more essential than we really give it credit? Should it be considered conditionally essential? Would arginine produce the same effect of weight gain in neonates, in children? Although that's my question, but it's always hard to test babies. A lot of the recommendations we have are AI or adequate intake because we really can't test them. We're making our best educated guess because it's not ethical, which is why we use baby pigs. But there really aren't that many studies looking at the dietary impact of proline in offspring. And although pigs can be used as models, would that directly translate to neonatal babies? And my question, as always, is going to be, how does that affect NICU babies? Could they, their needs are much different than babies to term. Would they benefit from proline supplementation as well? But it's hard to test. Proline, throughout this paper, proline is mentioned as being conditionally essential and especially essential in wound healing in pigs and human beings. But funny enough, proline is not used in supplements for wounds. Currently, there's no recommendation for proline. In fact, when we talk about wound healing in my profession, proline has never come up as an essential nutrient that's going to lead to healing at a faster rate at all. Protein in general is needed, but if you're eating arginine, you're going to get proline if the body needs it, and it's going to be a product, of course, because that's how it breaks down. So even though proline has not been mentioned as a wound healing element, arginine is. Arginine and glutamine are often in supplements. In fact, we use something called Juven for wound healing in the hospital. It has HMB, glutamine, and arginine. So, is it possible that maybe looking into future research, I think it's warranted to do human studies with proline supplementation, specifically with wound care with an IRB, is what I wonder. And I think would be next in the world of proline from a dietitian standpoint. Thank you for watching, And good luck on your final exam, everyone. Hmm.